Hello, everybody, and welcome to today's session in the certificate program in Python for algorithmic trading. This is the introduction and overview session, and my name is Yves. I'm founder and managing partner of the Python Quants, and I'm also the program director for the certificate program. The purpose of this session is indeed to provide an introduction. Among others, we will see a few cases which are meant to whet the appetite of what to expect during the program. But for sure, it should provide an overview so that you know what to expect, when to expect it, and maybe also a little bit more detail about what the single areas are for and how they fit together for the overall goal later on, maybe to then indeed deploy algorithms automatically executed, maybe in the cloud. This is what we recommend. So bear with me. I think after the next 1.5 to 2 hours, you will actually then know quite a bit more with regard to what to expect for the program. Let me get started with my slide deck here. I have prepared here the agenda. So we have 13 points today, quite a bit. Not every point is lengthy. Some of them are pretty short, but we will have a focus, for example, here on the case studies and the demos. What I mentioned, the other parts before are meant to indeed provide the overview that I mentioned as well, so that you see how the single elements of the program fit together and what to expect in the single areas. I will get started with the introduction about what we do. This is pretty short, just a few minutes. Then also a pretty brief overview of the program itself. And then the single elements. I will comment on the study plan and how to work with it, how to follow along, and also in combination with the weekly orientation emails. And I will close today's session and presentation with the points 11, 12, and 13 about data-driven finance, AI-first finance, and a few words about the importance of practice. The first part, the introduction, a little bit of background about what we do at the Python Quants. It is all centered around Python for finance, not only Python, to be honest, but let's say Python and open source technologies. But of course, the focus lies on Python. With regard to finance, we have a few main areas. One of them is financial data science. The other is computational finance, and of course, algorithmic trading. And through all these three main financial areas, we are applying more and more techniques from AI, such as machine learning and deep learning. With regard to these topics, we provide trainings online as well as live, offline, so to say, for companies or public training like boot camps. And we provide services to financial institutions around the world. We organize certain events, such as bigger meetup group events, for example, in London and across Europe. I've written a few books that you would see. We run the platform that you would see today in action as well, which we call the Quan Platform, or pqp.io, if you're asking for the URL. And we've open sourced several packages, libraries. The biggest and most powerful one probably is DX Analytics. For more background, please visit tpq.io. From there, you'll find further links and resources. At the core of the training that we provide is the Quan Platform. Here you see now the URL, pqp.io. You can do quite a few things there, but in our context, the major purpose is indeed to provide a platform, for the delivery of content, let's say of code, Jupyter notebooks, videos, but also to provide an execution environment where you can execute the code, not let's say 100%, but most of the code directly on this Quan Platform, and where you also have things like a user forum where you can ask questions and can expect answers, for example, within 24 hours. For those of you who haven't seen me live, here a picture that I personally like because it's an action where I was giving a talk about blockchains in London quite a while ago, and the link to my personal page. The personal page basically is also almost exclusively about Python for finance. You find resources to my talks like YouTube videos, slide decks, codes, gists, GitHub links, and so forth and so forth. So if you don't get enough out of the program, which I really doubt, you might visit hilpisch.com and get even more resources for our major topic. Here are 3 books. The best-selling one, so to say, is the middle one because it's the most general one. The derivatives analytics with Python one is pretty specialized. It's a quant book with regard to derivatives pricing, hedging, simulation, calibration, and all these topics. Listed volatility and variance derivatives is even more specialized in the quant field with regard to a single product category only. But Python for Finance was meant and is meant to be kind of like a reference work for all those who want to apply Python in the financial field, and the second edition is about to come out soon. I'm really now in the final stages to finish and polish it up, so expect the print edition to come out later in the year. The early release version is already out, for example, on Safari Books Online, and soon there will be all chapters, and finally, this is then the major milestone, the print edition as well. But it will also, as we would see, be already a major part of the certificate program. So no need to wait any longer. We will make use of the new and updated content during the program already. Then, if you like, I've written a 4th book about Python and finance. This is the PyAlgo one, which is at the core of many courses, programs, classes, and in particular at the core of our certificate program. In PDF form, it has close to 500 pages, not exactly, some 470, 480 pages as it stands right now. And once in a while, we update it with regard to the code base or when APIs change or when packages change. So this is the beauty of having an online resource. Once you get the print edition out, it's simply printed and usually not changed anymore. But here I'm planning to do some updates once again pretty soon. But currently you'll find there like over 11 chapters, resources with regard to the major topics that we will cover during the program. So if you like, this is the 4th book, but it's not available in print because we change it that often, and therefore the online format might be the best and most efficient one. Then we are working currently, so with regard to the intro about our company, the Python Quants and myself, we're currently working on what we call the AI machine. It's supposed to provide a platform for the standardized deployment of AI-based algo strategies. Idea is that you focus on research and strategy development. The AI machine deploys robustly and reliably. So you have the idea, you backtest it, and you say, well, that's it. And then you deploy it via the AI machine, and the AI machine, so to say, takes over and then takes care of the strategy. More details later in the year. It's not yet out there, but be assured we will inform you once in a while, or if you're interested in what we're doing there, drop me an email and I can elaborate on that. Yeah, here like 2 links to some profiles. Somebody say, well, what was it about? What the Python Quants is doing? There are 2 PDF links that you get here. Both of them point you to 2-page profiles, and both, I guess, are 5-minute reads. So whenever you want to remember what we do at the Python Quants, here are kind of brief summaries of what we do. Then I want to point you here towards our strategic partners. For example, we work with Thomson Reuters. I will have a case study of Thomson Reuters, the Icon Data API today. We collaborate with Fitch Learning, for example, with regard to the organization of events like Bootcamp and the CQF Institute in this regard, and HEWSR, which is our partner with regard to the certification. Of course, also a very important partner, and in particular here for the certificate program, because this is the institution that, after all, in combination with us, so I will sign it as well, issues the official university certificate. Yeah, that much about the background. More, as pointed out before, at tpq.io. But now I want to get to the program itself. We have quite a bit to cover. It's a 16-week program. lots of content, and we try to improve it for every round. So I'm every time I'm excited to get into the next round, because we will add new stuff, improve things, and work together hard to put you in a position that you will be able on your own to deploy your algos in the cloud, to come up with good ideas, to backtest the ideas in vectorized fashion and event-based fashion. So this is what the program is about, to empower you. And in this regard, we indeed have grown it to a larger program with lots of content. We have 150 plus hours of, basically it's more than 200 hours of instruction. We have thousands of lines of code that you can recycle, that you can make use of. We have more than 1,000 pages in PDF. You don't need to print it in PDF or read it as a book. It's all online on the Quan Platform. That serves as documentation and as reference, and it's growing and growing, and we are adding and adding. And what we have added recently and what we're going to add during this round, I will elaborate on in a few minutes. So here, another view on all the resources with a little bit more of a visualization here with regard to books and online content, Jupyter notebooks, pre-recorded video instruction resources almost, and of course code, because this is in the end let's say a Python programming course against the background of finance and in particular algorithmic trading. But we will also cover things like tool usage and deployment in the cloud, or usage of Docker containers. So a little bit broader than just kind of the core part of Python, and of course beyond just like coming up and backtesting trading strategies. It's kind of like from A to Z, from the very beginnings until the deployment, and even after deployment in this regard. So when we have a more topical look at what the program covers, of course, Python is at the core, and we do get started with the basics. Some might say even the very basics. That's fine, because I know not everybody is kind of already a full-fledged, full-stack data scientist, nor kind of like a PhD in quantitative finance. So we have added over the course of the last 2 years many elements that are targeted specifically towards starters, be it in Python overall or with regard to Linux-based tools. So basically we introduce and explain everything that you will need afterwards, because many people say, well, what do you expect? I don't have experience in this regard or in that regard. And we say, well, this is kind of a good idea, because many people ask us, why not put some more content with regard to topic A, B, C, from a basic level on in the program, and this is what we have been doing. So Python tools like IPython, Jupyter, Docker containers, cloud instances, basic idioms, control structures, linear algebra, basic finance, so all the fundamentals are basically covered and touched upon. Of course, this cannot replace, let's say, a full master program in financial engineering or whatever jumps to mind in this regard, but we try to provide you at least a reference and to give you the chance to go from there and maybe go deeper if it's of interest to you. Then we have the part about the financial data science. We'll work with historical financial data, where we apply machine learning and deep learning, like deep neural networks, do prediction and backtesting. So this is then really at the core, where we say, well, we have covered the basics, we know how to work with the tools, and now let's get started crunching the numbers, working with the financial data, be it end of day data, be it tick data. This is what we will do there. And on this basis, we would then say, well, let's get closer to the markets. And getting closer to the markets means that we need to be able to work with streaming data. Maybe we want to even visualize streaming data. We need to transform our algorithms to online algorithms, meaning that they digest data in real time and receive data incrementally, step by step, and do something with it. And also to be able, of course, to do real-time communication with platforms or other, let's say, technical entities in this regard, just to place orders, for example, or to look up account status or whatnot. And of course, online platforms and APIs are a very important topic here. So if we are not able to work with data in real time and to connect to the world out there, everything else remains somewhat theoretical and sandboxed, but we need to get out of the sandbox in order to get it up and running in the real world. So the fourth part that you see here is all about your experience. So to earn the certificate, so to say, you should be able to do it yourself. It's not like that I'm expecting here me to present everything and say, yeah, fantastic, like having watched a new movie, cinemas, and going out and say, well, this was kind of enjoying. No, you should be able to do it on your own. And this is kind of like the measure, the only measure in the end that counts. That you say, well, I was able to put it up and get it running. So therefore, do it yourself here as the guideline. You should be able to backtest your own strategies, to write your own trading code, your full week experience, including P&L. You should then write your research project in order to earn a certificate. So this is kind of the major milestone. It's not that you have put in like just the hours. It's indeed during the hours you should acquire the necessary skills and know how to get it up and running on your own. So with that background, I think now you will see how the single elements that I'm going to comment on fit together and what purpose they fulfill. So finance with Python I've put here first because it's indeed the intro class, the intro course in the whole program. So this is about finance with Python, and I typically say when I talk about it, it's a gentle introduction to finance, Python, and the combination of both. So by gentle introduction, I mean it's not kind of the goal to work with the largest data sets that fit into your memory, nor to apply the latest and very greatest machine learning techniques. It's about what me as a financial economist, I've been studying at university from the beginning, like static two-state economy, fundamental theorem of asset pricing, static three-state economy, dealing with market incompleteness, static multi-state economies, generalizing the state space, and dynamic economies to model uncertainty over time. All stays in a discrete world, but since we are doing some programming work, discrete time finance is usually the right choice. So even if you say, well, I don't want to become kind of a financial engineer doing this program, okay, that's valid, but it's kind of nice from my point of view to see how the single Python idioms, concepts, approaches are introduced based on such a financial problem model context. So this is what it's supposed to be. It's not standalone that we say, well, we go here through dry theory. No. Basically, when a notion is introduced from finance, it's kind of like the direct link is provided, let's say 3 sentences later, to Python and how you would model this in Python. And thereby you learn like the two at the same time and on, let's say, a level where basically everything could be done with pen and paper on your own. So it's not that we deal with, let's say, gigabyte data or whatnot. It's the simple case, and based on the simple case, the notions are explained and they carry over then hopefully easily, intuitively on the more complex stuff. So when I introduce the platform during the case studies, I will highlight what you see here again. We have often like of the combination of 3 elements on the platform. The first is that we have the documentation in a written form, so where there is some code in there, text, a little bit of math, other media like plots and so forth. Then we have like the videos, this is on the left hand side. Then we have the videos from the recordings, or we add something like from the live sessions maybe. And you will see here that the code is discussed and to go through the code step by step of what is here at the core of the documentation. So there is the code, there are the videos where we talk about the contents from the left hand side and go through the single elements that are presented code-wise and discuss also, of course, the financial concept. So you have kind of full-fledged multimedia combination here. So you have something that might feel and smell like a book, and then you have the video recordings where the explanations are provided, and you have the code themselves where you can go through, can do adjustments, or can add your own stuff and so forth. So this is, I think, the beauty of modern technology, that we can provide this in an integrated fashion on the platform. But again, it should be a gentle introduction to finance Python and the combination of both. We will get to this later on again. Then we have tools and skills. So here's one of my favorite quotes. Some of you might know I'm a martial artist, basically since I'm a little child and doing it since decades now. And here is from a martial arts context from one of the most famous samurais who lived a few hundred years ago, the Book of Five Rings, one of the classics there. And it says, well, in building a house, there's a problem of the selection of wood. It is essential that the carpenter's aim be to carry equipment that will cut well, and when he has time to sharpen that equipment. So this is the quote that I like to use to introduce the tools and skills part, because we need tools in order to do development, in order to do pick one topic: backtesting, deployment, coding, debugging, and so forth. So tools are essential, and skills, of course, come here into play at the same time. So we need to know how to work with the tools, how to apply them, how to combine them, and also here how to sharpen that equipment. And this is what tools and skills is about. And when you have a look at the topics that are covered there, we have basically three parts: basics, development, and distribution. So we try to cover, let's say, the whole value development chain in Python, where we start with Python installation and environments. We cover both Mac and Linux environments. So they are pretty close, as well as Windows, where there are some differences, but all is basically covered in this regard. Then Docker usage and Jupyter Notebooks as well, here divided into the Mac Linux world, and also on the other hand Windows. Some might say, well, why do I need Docker? I hope you will have fun with playing around with Docker. For example, if you do your stuff on Windows, you can run easily certain Linux distributions and so forth. You can set things up, test it easily, and later on with a single command get rid of your container. So there are multi benefits. Also, when you want to deploy something, you can first develop it in a container, then deploy the container on the cloud. All nice and important topics. And many people say, well, first I haven't had a clue about Docker, but now I really enjoy working with it, and it's even fun to work with it. That's what many people say, and I can only confirm I have fun there as well. Then cloud usage, I will show you a little example about how to use the cloud. Again, this is here divided into the Mac Linux world as well as Windows, and for all throughout, we cover basic Linux tools and shell basics. So after the basics part, you should be able to not only crawl, but maybe walk. And the running begins then hopefully with the development, where we cover code editing with Vim. This is an editor that I use on all platforms, and I work basically, even though I work primarily on Mac, but I need and I work on Windows and Linux as well. Of course, then a combination between a couple of tools for editing, logging, and debugging. Doc test, unit test, Git version control is covered. But when you say, well, this is now my package, this is my code, I want to share it with the world, with the Python world, be it just with your colleagues within a corporate context or with the broader world, then the distribution aspect comes into play, where we cover Python packaging and how to document it, what tools are there like Sphinx, code hosting, how to put this on GitHub. And we have also a case study here which combines all the other elements from A to Z and shows, well, this is a pretty simplistic project, but the project shouldn't be the major point. We want to cover all the elements based on such a simplistic project. And the major goal here is learning to use modern and proven tools for Python development and deployment. And when I talk about proven tools, this might mean tools that are around since decades. But nevertheless, they might be modern. But in the Linux world, we sometimes have the case that they are still used by thousands, or sometimes 100,000 around the world, but they date back maybe 15, 20, 25 years even. So, and we try to provide you with the best here to simplify and make efficient your Python coding efforts. When we have a look at the single tool world, so to say, we have here like cloud instances, virtual servers that we cover, Docker containers, the Python interpreter packages and tools, Jupyter notebooks, terminal editor, IPython and Vim, so on every infrastructure. So this is basically kind of at the core of the tools and skills part that we say, well, afterwards, you not only know about Python, you also know about how to deploy it in basically every different scenario and environment. Again, here we have the combination, and you see there are a few more videos, a few more sessions there provided of videos, instruction, live instruction, and here we provide a slightly different form of the resources, usually here presented as GIS, because this is more about codes, snippets, single elements, and we expect you, for example, to use this not on the Quan platform, but rather on your own infrastructure. So we provide it also a little bit on the outside so that you have an easier time to get access to. But again, here the major starting point is the tools and skills part, where you get access to all the modules and the videos, and where you can watch every single video on the Quan platform. Python for financial data science. Now we are getting closer to the core, assuming that we have covered the basics with regard to finance and Python, assuming that we have somehow mastered the tools and skills to do it. Now let's get to the financial data science part. So working with financial data, doing the analysis that we want or need to do. So you see, again, this is kind of a broad and comprehensive set of topics that we cover there. 3 areas, again, the basics and the data science part and mathematics. So the goal here is to cover the most important Python idioms, techniques, and packages for finance. This is based on my book, and it starts with Python data types and structures, numerical computing with NumPy, data analysis with pandas, object-oriented programming. So this is now, let's say, the Python basics part, where of course we rely on things like Jupyter Notebook and maybe the editing capabilities of Vim or wherever you want to work, or IPython if you prefer to work on the shell. And these are then the basic elements that we need in order to get started with data science, doing visualization, working with financial time series, being able to perform efficient input-output operations, which means reading data from different sources like CSV files or, let's say, relational databases, for example, and writing it in an efficient way as well. With regard to the Python code, we have a dedicated module here about performance Python, also a dedicated chapter in the book, in the Python for Finance book, how to speed up code. So this is something that you would typically do in a targeted fashion where you say, well, I came up with my code here. Let's make an example, a simple one, 500 lines of code. It's not fast enough for my purposes. Then you would get started with profiling the code. Where are the bottlenecks? Where is most of the time spent? And you might figure out that 15 lines of code consume, let's say, 80% of the time. And you would say, well, let's speed up this part in order to get the most out of my implementation. And this particular module presents then techniques to speed up your code. In addition, here to complement the fundamentals with regard to financial data science, we cover mathematical tools. So if you say, well, I have an integration differentiation problem as one example, you find a little bit of background here. Or stochastics. If you say, well, I need to simulate random variables or stochastic processes, this is then the module to go to. Or statistics with regard to figuring out whether time series data shows a normal distribution with regard to the returns, or mean variance, portfolio theory, for example, so working with first and second moments of distributions, and then doing a minimization, optimization techniques. This is what you find, for example, here. And then there is the special part, dates and times. And this covers like 3 areas where you get access to date and time. Functions and functionality in general. This is basically Python itself with datetime. This is NumPy, as well as pandas with its timestamp object. And I think in finance, you have all the time to deal with dates and times. So therefore, we have this special module as well. What I forgot to mention is that the statistics part also comprises basic approaches of machine learning. So this is a recent addition, also addition in the second edition of the book, that we cover basics with regard to unsupervised learning, supervised learning techniques, mostly with regard to classification, as well as, for example, deep learning techniques based on deep neural networks. So this is also here introduced on a, let's say, more fundamental level. In the Python for algorithmic trading part, we will then use this more from an applied perspective. Here, kind of the introduction, later on the application to financial data. Again, we have this combination of three elements. We have the documentation in written form with code, tables, text, and so forth. Then we have the video recordings of the single session. So here you see the number of the recordings already available. And you have, of course, access to all the Jupyter notebooks. Exactly the code that is used in the text and that is also used for the book itself. So again, we cover here the most important Python idioms, techniques, and packages for finance. And of course, you see it here, NumPy, arrays, and pandas, and so forth will play a major role. And all this against the background of the second edition of my Python for finance book. Then Python for databases. I said we always try to improve and to add value to the program. And this is an addition from the previous round of the certificate program. And we thought, well, it might be nice to add more about databases, because in the other parts we touch upon database technologies. But of course, in our field, we deal in so many corners, and companies on large scales deal with huge amounts of data and make use of databases. So for a number of reasons, I think it's good to know what Python can do for you in this regard. And when we have a look at the overview there, you see after an introduction and motivational session module here, where a few problems, so to say, are mentioned and examples are provided, then we cover in this class MySQL as one of the most popular open source SQL-based databases, SQLite, which comes with Python as batteries included and is already pretty powerful. Then MongoDB as a NoSQL database. It's an object-oriented database. Store works somewhat like a key value store. And on the other hand, we have more Python specific things. So here you see PyTables, which is based on the HDF5 standard, which allows us the pretty efficient and fast storage of, let's say, NumPy data, pandas data, in form of data frames on disk in binary format. So pretty efficient combination. SQL Alchemy, it's also Python package, which allows to work with relational databases, SQL databases, but in a more abstract fashion. So in theory, you should be able to write your code Pythonically in an object-oriented fashion and simply replace your backend if required. So you might get started, I always say in theory, because it usually doesn't work to 100%, but close to. You might get started with SQLite, and in the ideal case, you say after your prototyping and development phase, now we want to scale for production, and you say, let's replace SQLite in the backend by MySQL. And this is actually what SQL Alchemy allows you. B-calls might be considered here a little bit like a exotic topic. It's a rather specialized columnar data set storage capability, but it allows you to work with pretty large data sets in a pretty efficient way if the data sets satisfy certain conditions. So speed is here, and efficiency and also compression are topics that are of higher importance here. And I hope that when you get through the materials, you will see that there is kind of a place for B-calls, in particular in our financial space, and for what we need to do there. And last but not least, there is a comparison provided between the introduced technologies here with regard to how to work with them, but also with regard to how efficient they are, let's say, with regard to their performance. Again, here the combination of like video recordings and the instructions on the one hand side, also like certain Jupyter notebooks, but also here a gist once again, and you see here another screenshot. So this whole class, for example, is based on the assumption that you're able to, and I pretty sure you will be able, after you have gone through the tools and skills part, able to set up a cloud instance, and you have a separate environment where you run all these things. You install here, for example, this is what is shown here as this purple screenshot, where you configure your own MySQL server and set this up like for like the big web page infrastructures out there. And we will use it, of course, in a financial context. So making use of database technologies to efficiently manage large financial data sets. This is the major purpose of Python for databases. Python for Excel. So this is something we must openly say stopped including in the program, but I've decided to re-include it and to come up with new stuff in this regard, because still around the world in our financial industry, so many people are still using Excel. And I think if you get the combination right with your analytical backend and Excel using as a front end, as a really kind of like the user interface, this makes for a powerful combination. And here what I say is kind of like combining Excel with the analytics power of Python. And packages like Excel Wings, which will be at the core of this class, are kind of pretty nice and allow you not only to read and write from, let's say, a sheet within a workbook. It allows you to write some Python code that, with a few minor adjustments, might already be directly callable and applicable here from a VBA context. So basically, if you get it right, you can replace VBA more or less completely and make use of the analytics power of Python, data processing capabilities, plotting capabilities, and so forth, and combine this in a pretty efficient, neat way with Excel. So this is what this is all about, and I will even have a pretty brief case study just again to whet your appetite if you haven't used it yet with regard to what to expect from this part. This might not be, let's say, of interest for everybody, but in particular corporate context, banking context, larger institutional context, I'm pretty sure there are many areas where Excel still plays an important role, and to know how to combine this in a powerful way, I think might indeed be then worth the while to study at least the basics and some more advanced topics. And I must say you can get pretty far in this regard. So on Windows, flexibility is a little bit higher than on Mac, but I can say this works basically on both Mac as well as Windows. Here I see my Mac screenshots, but we will probably do also sessions on Windows here, because we can then do even more when we want to combine Python with Excel. Just to name one thing, you can define, for example, user-defined functions that can be directly called from a Excel cell, let's say. This doesn't work in the same way on Mac, but most of the other things work on Mac as well. So then now Python for algorithmic trading. You see, it's quite a bit, even me talking about what we're going to cover, but this is now at the core of the core. Python for algorithmic trading is the name of the game, and in particular the name of the certificate program, and this is now the core class, which starts in the first week and goes until the very end. And all this is more or less driven by the idea that machine and deep learning techniques, AI in general, are kind of revolutionizing so many areas. And for me, being a economist and PhD in mathematical finance by training, for me it's kind of fascinating that, from my point of view, for the first time in history, the financial field is more driven by developments outside of the field than from the inside. So I'm not talking about regulation, but how people make the decisions, how people invest money, how banks decide whether people get credit or not. We all know these days that well more than 50%, some 70-75% of stock trading on a daily basis is driven by computers, not by human beings anymore. Other areas like FX trading will catch up in this regard. So we have kind of this big push, not only that we are, I don't know, as Netflix users, Spotify users, get recommendations from machine and deep learning based recommender engines. No, in almost every field, like self-driving cars, for example, which you can read about basically on a daily basis in the newspapers, is kind of driven by what is happening in this regard. And of course, trading as well. So the basic idea is the same as with self-driving cars. So a money-making machine should make the money on its own, and the self-driving car should drive on its own. And what we need is the same as people building a self-driving car: data, algorithms, and hardware. The hardware might be a little bit different, because people building a self-driving car, they don't only need the computational hardware, they need the driving hardware as well. But with regard to the approaches that are applied to the data, the algorithms that are used, and the computational hardware, it's basically the same thing. So optimization, training, learning, then testing and validation, this is at the core there. And automation is the goal. So to have something in the end that runs automatically, that trades and makes money in a systematic fashion, is not too dissimilar from that point of view than building a self-driving car. From two major angles, I guess it's even more simple, in the sense of, again, we don't need to build a car that moves in the physical world. All is done here in the virtual world, and we don't need to take care of, let's say, human beings that might get hurt or even killed by a car on the street. So we can lose money, that's for sure, but we are not responsible for a car that might hit a human being on the sidewalk. Nevertheless, tremendous input and influence here from an area originally beyond what we do in finance, and more is now used and applied in our field, and in particular in algorithmic trading. Here the overview of the basic building blocks. This now combines a little bit what we have seen already before and what is kind of specific. So here we have introduction, Quan Platform, Python environment and infrastructure, basic finance and complete and incomplete economy. So this is all about the basics. So tools and skills on the left-hand side. So this is what we need in any case, no matter what our goal is. I think this is the minimum level with regard to tools and skills and background that we should accomplish. When you see a red dot here, this means that later on one of my case studies and examples will be based on this topic. So I will show the Quan Platform, I will do a little bit about Python environment infrastructure, we will do financial time series management. I will show, this is all rather brief after all, so it will be intense during the program, but my demo will be brief, and I will also even show some online trading application here based on FXCM, one of our strategic partners in this regard. So we then have the data science part. We covered this with regard to Python for financial data science, the algo trading part, financial data, backtesting, predictions, streaming data, visualization, online trading, automation of algorithmic trading operations. So I see this is kind of a mix now, the broader overview, more details, of course, in the single parts that I covered before. And of course, experience. I said it before, experience is the major thing. Your practice, doing better than knowing. So this is something we should emphasize and stress from the beginning. Out of sample backtesting practice module, the single day live trading practice module, 1 week live trading practice module, and the final project. So this is really where you can test yourself. We originally had this as competitions, but everybody was saying, well, if I'm sorry, or not everybody, but many people were saying, well, if I'm sorry, I'm a little bit late, so I couldn't hand it in for the deadline of the competition. But this was a pretty valuable exercise for myself to figure out where I have blind spots, where I need to go back and repeat it. I collected over the course of this exercise all the elements that I was missing, and now I feel like better prepared to go the next step. So, and this is for me the ideal outcome. If people comment that and say, well, we have done a lot of theory, I've seen you doing it live and doing the recorded sessions and so forth, but now that I had to do it on my own, A, this was a good experience, and B, now I know where I stand and saw that I really learned quite a lot in this regard. This is really for me kind of the ideal outcome and comment that I would wish for in this experience part there. My thinking in terms of Python for algorithmic trading is usually based on these 7 layers. So now we are again 3 levels down the core, so the core of the core of the core. And this is now the red line, if you like. We start with the infrastructure, we deal with financial data, We should be able to formulate our strategies in the form of code. We should be able to backtest our strategies in vectorized fashion as well as in event-based fashion. We should be able to write connecting code, to write and maintain connecting code so that we are able to stream data, to work with data in real time. And of course, we need to connect to the platforms in order to be able to trade. So without trading, no algo trading. The algos might be there. We might have transformed this to online algorithms, but still we need to take care of the trading, order placement, risk management like stop loss and all these things. And last but not least, all what we are talking about should be automated. So this is the goal from before, like self-driving car should drive on its own and our algo should actually trade on its own. This doesn't mean that there might not be any kind of monitoring or intervention if something is happening. But we should also even automate things like stop loss, which we can do via auto placements and so forth, or take profit goals, all these topics. This might be here in the part of automation where we say, well, I'm convinced that my strategy has something in it. Now I want to let it run in the market. And this is about the let it run robustly, reliably, and in automated fashion. Now, after this brief, but I guess comprehensive overview of what to expect about the study plan and how to work with it. So here you see a version, and intentionally I have left it that way because yesterday, 2nd of September is when I updated it. Here is a little bit of an overview. This is for US guidelines. I can only recommend that you read through this carefully because it explains what is in the study plan. But the core, of course, is the schedule here, where we here see highlighted the week number 1, where we have the core certificate program, videos, contents, topics, Python for financial data science, tools and skills, the reading material, and the live session. So here's just one, and optional resources, also as it says, optional. And usually optional means that basically everything that is covered there is covered in other videos, resources as well, or live sessions. But if you're interested in a second view or another take on it, you might visit these resources as well. So I said this was from yesterday, and here I'm providing the link to the PDF file. And this PDF file is updated as we go. And I've updated it today, 3rd of September. And you see that there is now another live session added, the Q&A session on 7th of September. And usually it will be updated once a week. Might be that there are some intermediate updates, but you should be able to discover here when the last time was when it was updated. And we go through it week by week. We add live sessions, we might change things a little bit, but this is the basic guideline. This is kind of like the framework according to which you can study. I know, and many people ask me, say, well, I'm a family guy, I'm a father, I'm a husband, we have dogs, and I have a full-time job which is really demanding, working well more than 50 hours per week. I'm pretty sure I cannot keep up with such a schedule. And of course, everything can be done in a self-paced way. All the live sessions will be recorded and put on the platform, for example. And you might say, to make a simple example, 12 weeks is, well, too many for me, or too few, the other way around. It's too fast. I want to do it in 24 weeks or 36 to make it simple. And this works basically, but the sequence should be the same. So this has some sense in it because certain topics expect you to know about other topics that have been covered before. So the sequence, of course, should be somehow kept, but you might say, well, I take a little longer. Or you say, well, I will have a week off next week so I can catch up, and then you phase in again to the plan. You have all the freedom in the world there with regard to how you study, when you study, but this is kind of what, let's say, 2/3 of the people that, or let's say 50% of the people that do the program basically in the end do and follow along over the course of 12 weeks. And then we have the practice part here, 13, 14 to 16, which ends with the final project preparation. I can say already most people take quite a bit longer. And the major reason here is that they say, well, I have this fantastic topic all the time in my head, and it takes a little bit longer than just 2 weeks. So is it okay to work like 6 weeks on it? And usually I say, well, of course, this is not a big deal. If you want to or need longer, or for whatever reason you're traveling for business or whatnot, no issue in this regard. You have all the flexibility, but from experience, the closer you're able to follow along, the closer you're able to indeed go step by step, as shown here and as repeated and re-emphasized during the weekly orientation emails, the better it is. It shouldn't take too long because, of course, we know this. You will forget stuff from the beginning when you reach the end. But this is your guideline, and expect more weekly orientation emails to come. This is what we do, usually Monday. Sometimes it might be Tuesday morning, or it might be Saturday evening, but usually it's Monday, with updates and a few comments to what has been and what is ahead of us, so that you should always be fully aware of where we are, where you are, and what to do next. So that's the study plan, which will be updated regularly. This now already leads me to the few case studies and demos that I have prepared. The first is that I want to do a quick walk through the Quan platform. Then I want to show you that it's not too complicated to work with the cloud, but usually when I say that, some things happen, unforeseen things happen, but we'll see. Then I show you how to work with a, let's say, professional data source like Icon from Thomson Reuters and Plotly, and we will briefly discuss random walks. This is the background. I will also show you some code and the application of the code for streaming data and streaming visualization. Then a very brief example about Python, pandas, and how to combine this with Excel, that you get an idea. And last but not least, a quick walk through a Jupyter notebook, which combines a few of these elements and has indeed some trading elements in there, works with streaming data, places some orders and so forth, so that we get a feel for the algo trading side itself and not only about the tooling. So this is meant indeed just to whet the appetite. This is not, let's say, an instructional approach where I say, well, these are the 10 steps. Now we go step by step. No, I would show it, and you should lean back and have a look at what is happening. All the details for every single topic that you see here will be provided during the program at the respective time a week when the topic is scheduled. So I will get started with the Quan platform. Everybody should have access to the Quan platform, and I'm getting logged in here. And you see on the left-hand side, this is the major panel here. This is the navigational panel, where you see that I have quite a few folders here. I'm not going into this here in that much detail. What I want to use here is FinPy Git, and you see this is related to finance with Python, and this has a few notebooks. So this is not a full-fledged, let's say, file manager. It just shows the Jupyter notebooks. Here we have the tool side of things, and there is a full-fledged file manager which shows you more stuff. So for example, here, even on the highest level in the root folder of my account, we have some files that I haven't seen before, like some Python script here, an example Python script, and so forth. And I can navigate here as well, for example, to FinPy Git, and I see also here in FinPy Git there is the a PDF which isn't shown here. So this just shows Jupyter notebooks. That's the major part here. Jupyter notebooks, and the file manager provides you access to everything. Now we have a few more things there, a few elements, but before I get to these elements, I told you before that I want to show you the resources of Finance with Python on the platform. And here, see Finance with Python under my trainings. And this is now the text Python, finance with Python. So this is this PDF, some 170 pages. And when I scroll down, you see it's quite lengthy. For example, here to chapter 4, you see text, some overview table where already kind of the combination of finance, mathematics, and Python here is shown, and you see there's usually a one-to-one relationship, or one to n to one, depending on what, but there is a relationship between the financial notion, the mathematical notion and approach that is used there, as well as the Python world. Like when we say here market completion by contingent claims, we have here in application something like the theorem of Lagrange, first order conditions, and we use NumPy, SciPy, Optimize to do it. So you see here already in the overview what finance, math, and Python here is combined. So this is your background there. So background in terms of, this is the text, explanations, there are equations, and this is, so to say, your study text. You have this already also available as a PDF here. I go on FinPy course, this is password protected. Might take a while to load. Everybody should have received the password as well with the first email. And this is now the same text, but presented as a PDF, so which can also be downloaded and used. For example, I know this from feedback where email used on the iPad, let's say, on the train ride to work in the morning and back home in the afternoon, because this might be a little bit more convenient to read on, let's say, a tablet in this sense. So we have the here the HTML version, which is also searchable. You have the PDF version. I will need to resubmit now the password. But of course, this is not everything. We also have here finance with Python videos. And when I click here on such a video, or for example, go to a module, finance with Python 1, you see here a video, and you also see related resources there. So there are also Jupyter notebooks found here. So finance with Python demo, finance with Python demo, and finance with Python live, 1, 2, 3. But usually you would get started with the video. See 2 hours 10. So I don't want to play this, but I might click through it. You see it's recording, mostly showing Jupyter notebooks and me talking about it and explaining what is going on. So that's the video that you can watch. And you have also here, when I click on it, the Jupyter notebook, which is used, the exact one here in the video. When you double click on it, you have immediate access to it, and you can execute it for yourself. So you don't need to copy something manually or whatnot. So this is all there. And you might have other resources as well. So like a PDF that you might find, and this is the slide deck, which is also hosted here. So you get access to PDFs as well. But you saw there is also a link to the slide deck, which is publicly available. So all the resources in a single place. I close the PDF, I close the Jupyter notebook, I can close the video, and this is all from module Finance with Python. Here's a link, a little bit of text, there is the video, there are the Jupyter notebooks, and in some cases there's Python code or a Bash script or a PDF, as you can see here. So we have basically everything here in a single place. And for Finance with Python, you find here 4 different modules. And when we have another look at the, I closed it already, I go study plan. And in the study plan, you see Finance with Python. Oops, I don't know what this is about. I know what this click meant here. You see here Finance with Python 1 and 2. Again, I don't know. I didn't click anything. This is magic technology, which behaves randomly. Finance with Python 1 and Finance with Python 2. Now, hopefully we got it. And this is Finance with Python 1 and Finance with Python 2. So if you're finished with Finance with Python 1, of course, you find then a video for the second one, Also some other resources. Again, here is a PDF, for example, which has some special thing here presented. So this is what you find then in the modules, and usually the names that you find in the schedule and in the study plan are exactly the ones that you find here. Sometimes might be minor naming difference, but I'm pretty sure you're able to find them all. So this shows the resource side of things, that you have here the Finance with Python training videos, you have and the codes, you have the text, you have the PDF versions, basically all presented in a single place. And here I have left it that way. You see, sometimes when you log in again, you see a button like this, update. And this means that with regard to this training, this course, there have been some updates, both text-wise and or code-wise. And if you want to get access to the latest version, you simply click update, and it said cautions, the current folder, Python for Finance, Py45, will be moved to old versions because you might have been working on certain code snippets, Jupyter notebooks or whatnot. This is all preserved, it is used to old versions, and you will get access then afterwards to the updated version. So now for me, it's successfully updated, and now I should have access here when I click on Python for Finance to the latest version. So this is intentionally that I left it that way. So whenever you see this update, you now know why there is an update button. It first asks you whether you indeed want to update, and we have made sure that your versions of maybe code, Jupyter notebooks or whatnot is preserved. So that's the basic idea behind that. This might hold true for Finance with Python. This might hold true for Python for algorithmic trading here, or Python for Finance, which I have now just used as an example. So I can close this and get back to the overview of the tools. So the file manager is something I've opened and I leave it open. Then we have the task manager. This says, for example, that there is a Jupyter notebook running. Finance with Python demo. This is a Jupyter notebook that I have been using before. You recall me opening this. I double clicked on it, and I can reopen it here and maybe do some further changes or whatnot. Or I say, oh well, I simply forgot to shut it down, and you might go and shut it down from here. So now I have no notebooks running anymore. A new editor. This brings me to some editing capabilities where you can, for example, create a new file. So this will be something like a Python script. So I have already one. So I would say, for example, algo cert.py, would save it on the current level. I would say this is a Python file, could be a script or module, and I would say import math, for example, and then print math square root of 2, for example, and I can save it. So this is a typical text editor that you can use. You, of course, can here open other files. So when I get back to home, there was here you see now algo cert.py. This is just the one that I created. Or you click on example py, you see another example, little Python script, and you can edit an existing file. So with regard to syntax highlighting, there are quite a bunch of things that are supported. So syntax highlighting for sure is not the issue, but I guess things like Python, maybe a little bit of HTML or whatnot might be the most popular choices here in this regard. So I can close this. And this was the editor part. Then we have the shell part, a new shell. And here we are on a full-fledged Linux shell. I can have a look at my file here. I can use things like Vim editing here as well. So when I say, like before, the example file, I can use Vim and edit this file here on the shell as well. So this would actually be my preferred way because this is something I told you before I'm using everywhere on all platforms. So for sure, much better in using this than the standard editor from Jupyter. And I can exit this, and I can basically do all the things. I can look up what my present working directory is and all these things. If you don't know about this, just wait for the single lessons in tools and skills, and then you can later on make use of this as well. There's a question with regard to the trainings, which trainings are there. So by default, the Python for Algorithmic Trading certificate comes without the computational finance one. This is about option pricing, hedging, and so forth. This usually comes only with the Python for Finance certificate. So if this is locked for you, it's usually due to the fact that it's simply not part of your package, because from experience, most people are not interested in that, and we have just retained this for the slightly more expensive program, the Python for Finance one. And in that regard, this shouldn't come as a surprise. There's another question with regard to the passwords for the PDFs. You have sent with your registration email, the first one, or the second one, which comes thereafter, you get the passwords for the PDFs. So please check the communication that came after your registration. It's not the password for the platform. So, but you have received it for sure via the registration emails. Please have a look at the registration emails that are sent after your personal registration. All right, that much about the terminal. We have a full-fledged Linux terminal here at our fingertips, and you see now two terminals are open. So obviously before there was another one, but I can here let it run, or I can shut it down depending on whether I want to later on get to that point. So new shell, user forum, important. So important because it's the best way to place any type of question. Of course, not about, let's say, personal details or accounts or whatnot. If you have a personal thing, please drop us an email. But as long as it relates the program, as long as it's a technical question with regard to contents of the program of a single class and whatever, then you should post it here. We have different boards like Quan Platform, certificate program related ones, finance with Python, Python for financial data science, Python for algo trading and computational finance. And when I click on Python for algorithmic trading, you see this is kind of a active one. If this says new, this means that on the Quan platform, I haven't had a look at the intro here, but this doesn't mean that I haven't read it, because if you are involved in a thread, so meaning you have asked a question or have been involved in the discussion, or like we ourselves, we are like involved in every question, every topic here on the board, you get emails there anyway. So usually I answer it from wherever I are by email. And you see here somebody has been asking about FinPy chapter, and there was an issue with regard to NumPy and why things are as they are. And I was answering here, and there was a follow-up question, and I answered it as well. So this is actually what you can use anytime. And you see we have syntax highlighting, so code highlighting. You can paste longer passages of code. This is actually a go-to resource if you have a question. And once again, we immediately get notified by email anyway. So don't fear that it's something that you put there and nobody will have a look for a week or two. We get notified by email anyways, and we actually ask you to put it here, because this allows us to have a central means and that multiple people can answer it and benefit others. Be assured, if you are not really, if you don't know whether to ask a question or not, be assured at least 2, 5, 7 other people are pretty grateful for you asking the question, because they might not have dared to ask the question in the first place. So the forum should be your go-to resource. Again, Python for algo trading is pretty active, but the others as well. So here in the certificate program, things organizational like where's the FXCM API key, people organize themselves and discuss something about Gemini, here backtesting, something with regard to Docker, streaming. You see, it's a broad bunch of things, and you can also search the board that is here. Well, here you see the search functionality, and when you say, well, where there's something about NumPy, for example, and you get then the hits with regard to NumPy. So you can also have a look at where your topic or the package or the problem that you have might have been raised before. Just in doubt, if you're in doubt, maybe you simply want to post a question. But by searching for it, it's growing over time. You might already find the answer you are looking for, because it's all centered and related to what we do here, centered around our topics and what we're looking at. So again, related to computational finance and so forth, if you have questions with regard to access to other classes, passwords and so forth, please drop me an email. I will answer them then individually. New classes or additional classes, passwords, and all these things, please drop me a line by email. These are typical topics that shouldn't be addressed in the user forum, because they are what we consider then personally, depending on your account, your subscription, and so forth. All right, this has been the tools part. And down here, I can close that one. I don't need the task manager anymore. Maybe I leave that one here open. And you see under my trainings now, a bunch of trainings. You also see a few things that are in my account visible, but not in your account, like edit trainings, edit course user, administration. So these are stuff that is only visible in my account. Then you have finance with Python, Python for algo trading, Python for finance. These are the 3 courses. Then we have the finance with Python videos, tools and skills, Python for databases, Python in a Linux environment. This is optional. For example, certificate program, where you get the majority of the things that are in the column algorithmic trading in the study plan shown. So this is kind of the core. And we have the live sessions, also webinars, talks, and special topics. This is a collection of my previous talks, workshops, and so forth, going back, like, let's say, roughly a year here. Webinars, live talks, 3-hour workshops in India, in London, about algo trading, about a few other things. And this is not even mentioned in the study plan, but you have access to all the resources, like here, talk from PyCon.de last year in October. So if you're interested and have some time left, you might go through it. There's an explanation. And when you click, for example, FXCM Algo Trading Summit London, you also get here the link to the slide deck that I've been using when the talk was given, and the video recording here as well. So this is an additional offering, so to say, not really advertised, but you get access to all this. Also, when I give new talks, I will post them here. Then online summer bootcamp is also optional material, which covers the core elements of our program in a more concise fashion. You get access to financial data science. This is the large class, in the sense of that it has many videos. When I say large, I typically mean many modules and many videos. And this is the one based on my book. And you see here the lineup of the videos and all the modules in this particular class there. These are ones that are replaced by tools and skills, and this will be coming soon in a new version. And TPQ Lab, maybe this is a special thing. This is a look behind the scenes, where I didn't do live sessions, but I recorded what I was working on. And this, of course, is all related to what we do here. So this is about the PyAlgo materials. Again, it's not at the center of what you should study, but if you're interested in having a look in what I do and how we work and what this is all about, this is what the idea of TPQ Lab has been. Yeah, this already ends the quick introduction to the Quan Platform. I spend a little bit more time on it here because it's at the core, and you see that all the resources are available there. Those that are created fresh or live that will be added, and you have access to it all, and you can watch the videos. And if you say, well, this week is kind of a good week for me, I want to watch 2 more videos, then feel free to do so. You can do this at any time. And here again, a view on the study plan, which should be at least your major guideline in this regard. So now, using the cloud for Python, why do I show this here? Yeah, because sometimes people ask, well, is there a vendor login? Am I kind of like bound to the platform that you provide? No. It's all open source. You can download everything. You should watch the intro video about the Quan Platform. This explains how to download files and so forth. But what we teach you is to basically do something like the Quan Platform. Of course, not this whole thing with thousands of users for yourself, but that you are able to use the cloud for yourself. So to this end, we use DigitalOcean, and here you see my DigitalOcean control panel. I have 4 machines up and running, and I'm going to create a cloud instance. Again, this is explained in detail during the program. Here I'm maybe just setting up a pretty small, the smallest droplet, $5 per month. I'm going to use Frankfurt location. I'm in Germany, so I choose Frankfurt. Maybe you want to use London if you're working with a London broker, or New York if you have a New York broker or whatnot. But this is up to you. You provide an SSH key. If you don't know what an SSH key is, be assured after the tools and skill part you will know. So I call this Algocert intro to have a name and that we know what we're talking about. And I'm now creating a cloud instance. And the value proposition of DigitalOcean is that this should take not that much longer than 60 seconds. So they say, well, within a minute, you have it up and running. And I hope this time it will be something like a minute. It's hardly ever longer than that. You see the bar here increasing, enlarging right before the stop. And afterwards, we will have a full-fledged cloud instance. It is region. What I was waiting for here is the IP address, which I, via single click, can copy. And now I'm going to my shell here, and I increase this a little bit, and I can SSH root now to the server. And there is a security question. And since I've provided my SSH key, it should now log me in. And you see, it was a matter of 3-5 minutes total. And I have a cloud instance up and running. But the cloud instance itself is just one part of the story. We typically want to deploy Python, and later on Python plus Jupyter Notebook plus plus our trading code and everything, code that collects data and stores our financial data there. So in that sense, I just want to quickly show how to install Python there and get Jupyter Notebook up and running. Not in a secure way, but how this is done securely is shown during the program. So here I first go and update the package index. Something we need to do, like housekeeping all the time. With Windows, you typically have this done automatically. With macOS as well. It says, well, shall I update your machine? And you say yes. So up, get, upgrade. I say -y for whatever is there to be upgraded, please do it. In the meantime, I'm going and look here for the Miniconda installer. And you see here, the Miniconda is something we use intensively to install Python. We're going to work with Python 3.6 here, Windows, macOS, here Linux. I'm working on Linux, 64-bit is the name of the game, and I'm copying the link address to this installer. This is something I will make use of. Here it is still updating, because depending on when the image of the server was created, there might be longer, larger updates or smaller ones only. But this is now running. We need to wait until this is finished. I see it here. It even does something with regard to the Linux kernel. So it's obviously a larger update, but it's finished now. And I will also install a few tools like htop, screen, bzip2 might be installed already. I don't know. wget should also be installed, but I need this. You learn about all these tools. Don't be afraid of the Linux shell here. Maybe you're an expert anyway, so you know exactly what I'm doing. And I think GCC, but GCC should also be installed. So I'm going to, it's a compiler. It now downloads that stuff. It is processing the single elements. And all in all, it shouldn't take just a few minutes overall, so less than 15 minutes in any case. And now I'm going to retrieve the miniconda installer. So this was my Linux work. I'm now already get started with Python. So I'm retrieving the installer. I have now the installer here, and I say bash miniconda. And this now asks me a few questions, and I say yes, and I go forward, and I say yes again. And here I again accept, and now it's installing my Python, so to say. Because on the server there probably was some version of Python, pretty sure. But I will have full control over my Python install. Say yes, and Python is installed. Let me restart Anaconda, and you see we have Python 3.6.5 from Anaconda installed, and I can say print hello algo cert, something like this. So my first Python line. But I don't have installed that many tools, so I want to go and install, for example, IPython and NumPy, no MKL. This avoids the installation of a huge package. It's now connecting to the server. As it says solving the environment, it looks what it needs to download. And we say yes. It's not opening if you're not opening, it's downloading and installing a few packages. This shouldn't be too long here. Once it knows what to do, it typically is an efficient affair. And we are done already. So now I can use already IPython here, which is now installed. I can import numpy as np. And now I'm already in the middle of my Python coding on the server. np random, for example, 10.6, and I'm throwing random numbers there. So I can do the same thing. Maybe if I like, just round this, and I get my random number. So I have Python. I'm on the server in Frankfurt, not where I live, but in the middle of Germany here. And on this server, beyond my local machine, I'm doing Python analytics. And the last thing I want to do now is to install Jupyter. This would then typically be our goal, to have Jupyter and to leave, so to say, the shell in order to then access the server via the browser, like with the Quan platform. This will be then, let's say, the individual Quan platform. Oh yeah, I should type it correctly. Jupyter, not Jupyter or whatever I typed before. Of course, spelling is important. And you should then have access to your own platform, if you like. Maybe you call it Algo Trading Platform or whatever. I've called the server AlgoCert Intro, that we exactly know what we are now doing and to which part this is related. And when I'm finished, I can simply destroy this cloud instance. It will only be built for 1 hour. So 1 hour is the minimum, and the billing is hourly. So this means that you pay only by the hour. And if you say, well, I test something for, like, say, 5.5 hours, you pay for 6 hours. And here we are just paying cents. And for a full month for this droplet, it would only be $5. And you can already do some proper stuff on the smallest droplet, no doubt about that. But if you have a higher workload, you might then say, well, I go to the larger ones, like let's say 3 cores and 1 gig, or 3 gig and 1 core, depending on what your requirements are. You have quite a bunch of options there. So when I say here create droplet, you see the overview, and I've jumped to the smallest one. Here's what they recommend. Of course, they want to sell you a larger one, but it goes up until 32 cores, 192. There are the faster ones, and you see also it increases in price. And this is not linearly, so you will see you pay more in relation to the smaller one, but this already can do quite a bit. So this is a good choice from experience for what we do, like 3 virtual CPUs in 1 gig. This is for $15. This already has quite decent storage space, 60 gigs. So, but this is in the end up to you with regard to what you want to do there. So this is now installing the Jupyter Notebook, and this will be the end of this little endeavor. There are a few larger packages. You see 86.7 megs. It's quite a bit. It's also updating a few things in the meantime. Now it's installing it, and we should be good to go in a few seconds. Final few things. And of course, when you now think, well, this takes a little while, and you've said just a few minutes, still after all, it might be 10, 12, 15 minutes, but you do this in general just once. And once you have the infrastructure, you then work on the infrastructure. You might say after a while, well, it's too small, I need to migrate, then you do it twice. But basically, it's nothing that is done all day and you need to wait that long. But here, I'm now simply starting a Jupyter Notebook. I need to configure this a little bit, IP 0, and I put it on port 888, and I say allow root. This is something this is all explained in the part, and this is now running, and it's running. I take this part here and I put this in here, but I need the IP address once again from my droplet here. From this particular droplet, I need it, and I need to put it up front, then 888 and the token. This is for security. And you see, I'm now working in the cloud. So I can now go and open a Jupyter Notebook on the cloud instance, where I do the same as before, import numpy smp, and do things like np arrange 20, for example, or whatever I want to do. This would all work. I can open something like terminal. Now in the browser, I don't need to get back to my shell anymore and can call htop, where I look up the resources, and you see the resources, indeed 1 CPU and 1 gig of memory. So that's already it with regard to what I wanted to show. That's not it when it comes to doing this properly, but you see the basic steps are just a matter of a few minutes, and I think it's pretty efficient, and everybody can learn how to set up their own cloud-based infrastructure. And I'm not saying the only purpose is to have a Jupyter notebook on a separate cloud instance. If you want to deploy algorithmic trading code properly, I don't think that there is any alternative to having this on the proper infrastructure. And proper infrastructure means in the cloud, 24/7 availability, security measures like against fire, access, and so forth. This is all what you need. You cannot run algo trading code when you trade your money locally on your desktop or on your notebook. So here I'm going to close this, and with that I might leave this. Later on I can destroy it. When I go to my examples, we now have icon, plotly, and random walks. Assume now you have your infrastructure locally or on our Quan platform if you want to get started there, or you are even at the point where you have your cloud up and running. I have now my local stuff here, and I'm opening this locally because for this particular example, I indeed need it, because I need to have something running, which is here the proxy. If you have a Thomson Reuters Icon Data API subscription or Icon subscription in general, you get access to this in programmatic fashion. And I'm using here data from Thomson Reuters to do my example. This is about the random walk hypothesis. I'm not going into details. I just walk you through the code and show you the examples. So this is, again, covered in some detail, but I just want to show you the results more or less. I'm doing some imports here at the beginning, and the versions are shown, and I'm connecting here to the Icon Data API. This is now requiring the proxy to run in the backend. I'm going to retrieve cross-asset data for some stocks, for the WIX, for Euro-US dollar exchange rate, gold price, and 10-year bond. So the data retrieval happens here. I'm retrieving the data for a certain time period until last Friday. And here we see the data that we've got. So far, I'm going to drop not a number rows, and we end up with some 409. So I think we missed out on a few here at the beginning, but this might have current technical reasons. I'm going to calculate the log return. So based on my data sets, cross-asset data set, I calculate the log returns, all explained in detail, trust me. The correlations here between the different time series, and now we plot the data. I'm using cufflinks, and cufflinks is kind of a nice library which makes use of Plotly. So I can, you see it here, I can zoom in and can analyze my data. I can zoom back. This is all interactive. I can plot the data as a histogram. This is now the returns data. So we get here an overview of the returns. And I can use, for example, the heat map option here to plot the correlation heat map between the different time series. So far, so good. But now we want to do a little bit of an analysis, and we are going to prepare a few lags. This is the function, 5 lags. I go quickly through this. And when I have a look at, for example, this one data frame, you see I have the original time series and I have 5 lags. I now implement ordinarily squares regression. And what we see here is the regression parameters given the historical lags of the index level. And throughout, I want to point you already to this point, we see that the most previous lag has a weight of close to 1. And this is already support for the random walk hypothesis, which in one particular form says that the best predictor for tomorrow's stock price, index level, instrument price in general, is today's price. And we see here that indeed, obviously, just taking today's price gives us already quite a good prediction chance, so to say, or accuracy for tomorrow's price. But we can have a closer look and can zoom in, for example, into a time series, and we see here visually, this implies that when we do such a prediction exercise based on the time series and our ordinary least squares approach, that tomorrow's price as predicted by my approach is basically today's price. So this is the weight of 1. But this is not really something about prediction. This simply says like, okay, I don't know what tomorrow happens. I say tomorrow is the same as today. And this is what we see there. So in this regard, we see prediction time series and the other one pretty closely related here with 1 day shifted. We can now analyze the results. We see here the value stacked. We calculate the means. We can then describe the data. Again, this is just here a quick walkthrough. Details discussed later on. And when we visualize the results, you see here, the results are basically the same for all time series. We have this large column here, the orange-yellow one, which is the most previous lag, and we have the others which are somehow around 0. So qualitatively, no matter what time series I take, we get the same results. When we take the mean, I think we get more or less the stylized fact here. It's almost exactly 1, this optimal regression parameter, as the average over our time series. Now you might say, well, intraday, this is where the random walk hypothesis breaks down. This might be the case. So I'm now going to retrieve intraday data for the pack. And we see intraday, indeed, we see deviation. So this basic finding that the first column here has a weight of 1, is close to 1, is not that pronounced anymore. It's still the most important element. And when we take the mean, it's still close to 1, but time series by time series intraday, there is a difference. So again, my focus here is not on the story itself. It's just to show you get access to the wealth of data and information from sources like Thomson Reuters via Python in a very efficient way. Here it is data that requires a subscription. During the program, we provide access to fixed data sets from Thomson Reuters. So I've asked that and we are allowed to. I also show how straightforward it is to apply ordinary least squares regression to quite a bunch of time series, and how efficient it is here to plot data interactively. It's just a single method call here. And we have an interactive visualization here with Hoover effects, and where we can zoom in into single parts here. So this is actually what this is meant to be. I would consider what we do here really at the core of the financial data science part. When we say, well, we have covered the basics, we have a basic notion of finance, we know a little bit about Python, we have our infrastructure up and running, then you would say, well, now let's do some proper financial data science. And this is what this part here is about. All right, this was case study number 3. Case study number 4, streaming data and visualization. This brings me back to the shell. When I'm here on the shell, I might simply stop that one, or I don't even need to stop it. I can exit here. That's fine. Exit. Now I'm local once again, and I'm in the right part. So I'm showing you now the code here of the tick server. This is a simple script which makes use of 0MQ, uses some random elements. And you see, this is just 20 lines of code with blanks and comments and so forth. But nevertheless, this little piece of code, when I start this here on the shell, this spits out now in randomized fashion simulated tick data for Apple. It's just meant, Apple just meant to be like a placeholder here. It's of course not Apple data, but I think everybody has some relation to Apple and we know what we're talking about. The data is of course sample data, random data, and it both arrives randomly at random times and the numbers that we see are random. So this is what we have in financial markets as well, but at a much higher frequency. So tick data for Apple is roughly between 1,800 and 2,000 ticks per quarter of an hour. So let's say between 7,000 and 8,000 ticks per hour on NASDAQ is the number of ticks for Apple. So here I'm doing it a little bit slower so that we with our human eye can still follow somehow along. Now when I open another shell, I can say, for example, I have a tick client there. So here is a tick client script. It's even shorter. And this is now simulating the retrieval of such tick data. So here, down there, I say now Python tick client, and I'm running this. And this now does a timestamping, pretty accurate timestamping, and shows exactly the data that is transmitted there. So if you follow along closely, the last line is always the same. So I can now go here and open another one, or maybe put this here, and I say Python tick client. I can have many clients, say even 1,000 clients, listening to the same server. So now 2 clients are listening and 1 server is sending. And this is what we see in the financial markets. Some sources like from Thomson Reuters, Bloomberg, the exchanges, they spit out the data as soon as it's created. And many participants in the financial market sit there and, technically speaking, of course, listen to what is transmitted by the data providers. So I have now one more example, and this already finishes it, because this shows already the basic idea. We need to be able to work with streaming data in real time. And based on such sample data, it is shown how to process the data, how to resample the data, how to place trading decisions on real-time data. Here the script is a little bit longer. It's a little bit less than 40 lines of code. And this is about plotting real-time data. The code is the same to retrieve the data, but it's about real-time plotting. So a little bit more involved, but nevertheless, I mean, the task of printing something is, of course, much more simple than the task of plotting something. So compared to the printing one, I think we are not doing too bad here with a few lines more of code. But let me start that script. So I'm opening here yet another one, and I'm starting now Python tick plot. This now connects to my Plotly account automatically. So this is how I configured the code. And you see now the tick data plotted in real time. So Plotly, you remember from my Jupyter notebook. And here now we have, it's a little bit large there. So we have the live data now shown in the plot. So when I zoom out, we see this now growing over time at the speed of how the data is retrieved by the little script. So of course we can zoom in and analyze that. You will find examples in the course material where also simple moving averages are plotted in addition to what we see there. So that's basically what this example is about. Streaming data in real time. We program our own server, so just to have a reliable data source that we can control. We write a couple of clients and not only implement like resampling techniques, trading techniques, we also show how to visualize data in real time, making use of here the Plotly streaming service. Important element of the certificate program. This was streaming data and visualization. I now want to show you a quick example, a brief one with regard to Excel. So here I'm closing all this. I can also close here all these code snippets that are now running, so it's not needed anymore, and I'm going to stop it. All right, so IPython, I'm going to import numpy as np, import pandas as pd, maybe from pylab import plt, and import xl wings as xw. So I haven't opened Excel, so maybe I open Excel first, so that we have at least the major program running. I don't need that stuff right now, so I'm now going to do and open a new workbook. So WB workbook is XW book, and when I call it that way, it opens in the back end a new book here. So you see book 1, this wasn't there before, and this is now just an in-memory version of the Excel book. And you see this was instantiated here via this call, and the workbook itself is book 1. You see here, this is book 1. Now the sheet, I need to specify the sheet as well as WB sheets, and I take the active one. So sheet is now book 1, sheet 1. Now I'm going to create some random numbers here. np random standard normal, maybe something like 12 and 5, for example, and I maybe do it later on. So then maybe an index that I want to have. Index is pd data date range is what I'm looking for. So I start 2019 January. I have a frequency of maybe monthly, and periods shall be 12 in line with my data set, and the columns shall be list A, B, C. So I have everything together to create now my random data frame, not random data frame with random numbers, and I say df is now pd data frame A, index is index, and columns we assign columns. All right, I know where this was my mistake here. I have 5 columns, A, B, C, D, E is what I need. So I have 5 columns, so we need 5. And now we have our data frame with random numbers. Maybe I do some transformation like df is df cumsum. This might then look later on a little bit more than a random walk. And we now have the data where we have calculated the cumulative sum. Now I might wonder, yeah, we have an Excel spreadsheet, we have some data frame here. What can we do now? Yeah, what I can do now is I have my sheet, and this sheet, when I define a range and I get started in the upper left-hand corner, all the Excel users know it, upper left-hand corner is A1 here. I define range A1 value, and I assign now df to this range. Here I don't see that much, but when I go back now, you see, oh well, like magic, from Python, I've written my data frame object now here to the Excel spreadsheet. Now you can get started and say, well, I mark this, I create a plot out of that or whatnot. But what I want to show you, and this is already the end of my example, is that I can also create a figure here. Fig is plt figure, and I'm going to do plt plot df. So it's plotting something. Now I can do sheet pictures at fig name plot update true. So these are 2 parameters, but the fig object is the important one. And when I get back here, you see suddenly I have here my Python plot in Excel. I can work with it. Now I might say, oh, well, I don't really like this. And I show you one more transformation that we say, well, what I typically use is the style Seaborn from statistical plotting. And when I redo the plotting here, fig plt plot, and I re-execute the adding, you see here now that the style of my plot is changed. So I have, on the Python level, I've created some random numbers. I've transformed and put the random numbers into a data frame with a date range here. I have the numbers there, and I've created a plot, and I've transferred the plot here to Excel. So this just to whet the appetite, what you can do, and you can do much, much more. You can, for example, use Python code like VBA macros and so forth, and really automate things on this level and combine Python with its analytical capabilities and here Excel, so to say, as your user interface of choice pretty efficiently and productively. So the calculations, for example, on larger data sets like gigabytes of data, which wouldn't work in Excel, can easily be implemented in Python. And you just present, for example, the results and a few graphics then on the Excel level. All right. So can close all this. This is all temporary. I would need to save this now, but this was just created on the fly, and I will delete it here on the fly. Don't save, and here I'm finished. I can say exit, and I will be done in a second. So with regard to what we got here, we are already now at example number 6. This is now about algo trading itself based on a platform. I mean, we can talk about trading, backtesting, and so forth as long as we like. There is the one point in time where we say, well, we need to get started trading. We want to get started trading. And this then requires a platform. And here I'm going to show you all this based on the FXCM trading platform. Please always read carefully risk disclaimers and author disclaimer or speaker disclaimer in this regard. So since we are working together, it's even more so important to understand all the risks and topics involved there. And here I'm getting started with a few imports. And even without having a demo account, we can get tick data from FXCM. This does for sure not hold true for every platform out there. So when I here import FXCM Pi, a package that we have written in cooperation with FXCM itself, so we support them with regard to the Algorithmic Trading Initiative. We see here we have a couple of symbols available. We define start and end here more or less randomly in July. And I'm going to retrieve now tick data, and you will see what tick data means on this level. We will see, I don't know, 1.5 or 2 million tick data points for a single week. So when I get the info here, you see this starts 1st of July, goes to 6th of July, 9 p.m. respectively, and we have a little bit less than 1.5 million, depending on the FX pair and week. You might get up to 2 million tick data points. So this is now already mid data and would already be, for example, quite tricky at least to get managed via Excel. So here we get a look at the head, and I can pick out a smaller set, which I can then, for example, visualize, again, using here interactive plotting. So this is a small subset of the data with a single simple moving average, which would already maybe consider to be a first step towards a strategy. But we have access also to candles data. Here I'm retrieving candles data, meaning we have access to data sets as 1-minute bars, hourly bars, and daily bars. So what we have here is hourly data for a certain period of time. And when I have a look, we see that we get bid open, high, low, close, and we get ask open, high, low, close. We can calculate mid values, some simple moving averages too, and can get them plotted like a typical SMA-based strategy. Can zoom in, can analyze that a little bit, zoom out, and can do all the nice things that we have seen before. But we want to connect to the API, and via the API, it will allow us to not only retrieve also in a flexible way data, but also to, here you see data availability is a little bit higher, but also to place orders and read out account information. So here I'm again retrieving historical candles data, and see here it's 309 is a relatively small data set. I can always get the latest 250 data points. And when we see here the latest 250 data points, this even means that we are now pretty current. This is September 3rd, and exactly from the last minute bar, this is GMT time, I'm CEST, so 2 hours before. So we get the latest available minute bar here. So it can get better and faster. All the data available as bars, but we can also stream data. So here it is shown that with a simple callback function, which just prints the data, and when we subscribe, this might take a bit, it now starts streaming the data. So we get real-time data as FXCM, as a broker, as a platform, is sending it, and we're retrieving it in real time. And here I'm just printing it out. I can print out bit ask high low here, last available, and when I'm finished, I say unsubscribe. So real-time data before, where I showed you my little example, was just fake data. This now is proper data from the broker that we retrieve here in real time, and we could base our online algorithm for trading directly on that. But the online algorithm should do something, and do something means in the end placing orders. So when I get started here, I have an open position. Let me open the trading station here in the browser. This one, and I'm signing in. This is now loading application, and of course retrieving all the data and so forth. And what I'm interested here is open positions. And I currently in my test demo account, I don't have an open position, but I'm creating an order for 10,000 euro US dollar, not including leverage. So it's 10,000, leverage needs to be included. Let me have a look at the station, and you see already now here we have a position 10,000 buy for long, and we see a real-time P&L here for our position. Euro US dollar bought at 116, long position, and the P&L in real time. But we don't need to actually have a look here. I can programmatically also read out the current position here. So I get the data via the API as well. Let's create another order, 5,000 euro GBP. And I have a second position here, 10,000, 5,000, second position is opened. Again, a look at the open positions, we see it here as well. Now I create a sell order and another buy order. When I check back, you see, oh, I have 4 positions, 10, 5, 2, 5. It's not netting here. So we see all the cross positions. And here I see them as well. Then I can, for example, close for all for symbol Euro GBP. And I can then have another look. All the Euro GBP positions have vanished. And when I close them all here, nothing is left. And my account is as before. You see all open positions have vanished. But I haven't done anything manually here on the trading station. All has been done here via the API using Python code and the wrapper package. I can get account information, for example, here an overview of what my balance is and equity and a few more. And last but not least, I want to show you a simple automated algorithm. But believe me, this is a dumb algorithm. This is just a time-based one, which places orders based on time. So it enters a long position, and after 7 seconds, it closes it. Then it waits for 7 seconds and opens it. So it's not the algorithm of highest intelligence, but it is an algorithm. And we can see here there is a position open, and like by magic hand, namely by our Python script or Python code, it closes out the position, and it reopens it afterwards. So this is what we understand under automated trading, like a self-driving car. With a self-driving car, this approach would be pretty dangerous because we have no control, no intelligence here. But with a demo paper trading account, no issues involved, no strings attached. While this is finishing up, it's doing like 5 rounds here. We can already leave this demo because this was the end. We saw we can get access to tick data, historical candles data. We can use the API to also retrieve candles data like 1 minute bars, current 1 minute bars up until the last full minute. We can retrieve real-time data via streaming approaches and callback functions. We can place, this is that part, and we can place orders, buy and sell orders. Here I'm just showing market buy and market sell order. We can of course place other orders as well, entry orders or orders with stop loss attached and so forth. And last but not least, a simple algorithm. So here, this was an algorithm, although you might, I think, agree, not the most intelligent one out there, but still it traded automatically. So when I close that one, we are now through the case studies, and I will come to the final concluding words. Data-driven finance is a topic that drives me. So almost all what we do is to be sorted into this particular field and idea and notion, data-driven finance, which basically means that we're coming from times where people were sitting on the airplane, on the train, or at the desk even, and reading the newspapers, informing themselves and basing their investment and trading decisions on what they read in the papers, what they hear on the phone, and simply what they can grasp on their own. And I still enjoy reading the newspaper, sitting on the airplane, traveling the world, but I'm pretty sure that it's only still, or not still, it is today, kind of just the minor part of investment decision that is based on such information resources. Of course, people, since we can almost say decades, are kind of sitting in front of the terminals like the Bloomberg terminal or Thomson Reuters Icon terminal. And if they're interested, let's say, in Apple information, they don't need to pick like 20, 50 printed resources. They simply resort to their terminal and they look up Apple and they get a summary, they get news, they get historical financial information, they get price data, tick data, whatever they're interested in, they can do. They can do comparison analysis and selections and so forth and so forth. And this, of course, is much more efficient when you know what you want to do. But still, this cannot keep up in general with, let's say, the financial data scientist who has access to something like the Icon Data API that I've been showing, where you say, well, here I'm retrieving tick data for a quarter of an hour only, and this is roughly 1900 tick data points, and I'm going to crunch that data. Nobody would ever like to print that many data points. Nobody ever would, I think, like to read through these vast amounts. And just think of like the S&P 500 and tick data for all the S&P 500 just for a single hour. This is pages and pages and pages of data printed, and nobody could ever process it as a human being, what's happening. But the machine simply doesn't care. And I'm not speaking of the biggest machines out there. I'm speaking of regular notebooks, let's say 8 gigs of RAM, 4 cores, 8 threads, and so forth. So this is already enough to crunch huge amounts of numbers. If it gets larger, of course, you need bigger, faster machines like in the cloud, easily scalable, available within minutes, and then you're done again. But not only with regard to the numbers, where machines have been traditionally strong, but also with regard to reading the news. So when you say, well, numbers, I agree, but I still like to read the papers with regard to the news. But the machines read the news as well, and they read it faster. So when a machine reads 1,000 or 5,000 articles per second, you're still like at the header of an article. And with regard to the Thomson Reuters Icon Data API, here you see that you retrieve data in same efficient way as we can retrieve structured numerical data, and then you can get drilled down to the text, the full text itself. Then you can apply natural language processing approaches and all the nice tools that the Python ecosystem and the machine and deep learning ecosystem has to offer in this regard. So this is what drives finance, the availability of data via programmatic APIs. For example, we're also working with Dow Jones, with the offering DNA, that you have access to more than 1 billion articles via standardized APIs. So the machines are taking over news reading for us, and we cannot keep up. Although, of course, as human beings, we like to stay informed, and this is good. So we can always apply our common sense. But still, when it gets to the masses of data that is available today, the machines are already at the front there. AI first finance. So for big data, for AI, for machine and deep learning, we all know big data in general is a prerequisite. And with the availability of the data, we can now apply the fantastic methods that I mentioned before that, for example, are used for self-driving cars, like Google's TensorFlow, and apply it to financial data. And here a quote from Yuval Noah Harari from Homo Deus, which says, dataism says that the universe consists of data flows. We have covered that one. And the value of any phenomenon or entity is determined by its contribution to data processing. Now we are at the point where we say what to do with the data. Dataism thereby collapses the barrier between animals and machines and expects electronic algorithms to eventually decipher and outperform biochemical ones. This is a general take on what is happening out there, but I think you can more or less one-to-one translate this to a financial context. In a book dated back or published in 2015, you can read already that today's algorithmic trading programs are relatively simple and make only a limited use of AI. However, this is sure to change. Artificial intelligence is beneficial in any domain where patterns have to be found in large quantities of data and effective decisions have to be taken on the basis of those patterns, especially when the decisions have to be taken rapidly. I really like that, and I can relate to this quote here. And I think to a larger extent, it still holds true. But we are working on the point that indeed AI might change the future. So in that sense, this is what I understand under AI first finance. Data is there. Now let's make best use of AI in finance. One of the first books to cover indeed rigorously and properly financial machine learning is the one by Marcos Lopez de Prado, which came out in March, and some of my favorite quotes out of the book here you see. And the last one I want to pick out: econometrics might be good enough to succeed in financial academia for now, but succeeding in practice requires machine learning. So this is how far we have gotten from the point of view of not only in academic. He has a double PhD, is also teaching, but he is running a multi-billion, beyond 10 billion US dollar hedge fund. And I think he knows what he is talking about. And my argument is not that there is nothing in patterns like these, not there is something in patterns like these. What I'm saying is a conditional statement, is that if there is something in patterns as we see them here, then for sure machines are much better at spotting, at identifying and acting on such patterns compared to human beings. So again, you might believe it or not. You might say this is astrology, or you have made already a fortune out of it. This, I think, is not the major point. The major point is that if we say that there is something in there, then we must acknowledge that machines are for sure much better at pattern recognition and acting fast and without emotions and everything based on such patterns. So in that sense, we have the financial markets we need to deal with. We have X, which is kind of the large data set, which is growing at an ever faster pace. The financial markets are data processors themselves. So financial markets, the major purpose of financial markets is processing data, processing information. And they come up with new prices and reactions, which is why. And we all know that markets are not, like in theory, linear and normally distributed. They are nonlinear, complex, and changing over time. And financial history was brain-driven in the sense that intelligent brains, nobody's arguing about that, came up with wonderful formulas. This is what I call the beauty myth here. Wonderful formulas, but once they have been tested rigorously, empirically in the financial markets, more often than not, they haven't proven to be of any use in the financial reality. Let's get back via AI in finance, or as I call it, via finance with AI, to the scientific method. And let's get started with the vast amounts of data. We have the tools and the capabilities at our fingertips. Let's apply maybe models and algorithms that are not that beautiful, that are more complicated, that are black boxes, in the words of certain people, but that might be a little bit more useful than the beautiful, simplistic approaches that we see there. So this is what I call data-driven AI-first finance. We simply start with the data, we mine the data, we apply the algorithms, which might have black box characteristics and so forth. But in the end, if this brings better results, I'm more than happy to apply the results when my money is at stake than using something wonderful, easy to understand, and easy to prove, but which has no worth at all in the real world. In that sense, I want to close with a few remarks about the importance of practice. So when you look at how people are trained in the professional business worlds, you find a tendency to focus on knowledge at the expense of skills. And this is true, and I'm coming out of this part as well, that you read text, you read more text, you read papers, you read more papers, but you're hardly developing skills. So everybody knows if you want to master the piano, if you want to become a world famous piano player, there's nothing around practice. Practice all day, all night, at least 6 hours a day, and then you might be on the right track. It's about skills, not about reading books about how to build piano, how people have composed something, about the lives of composers. This is all let's say, side topic and interesting, but you need to train your skills. And here, Anders Ericsson, one of the researchers in the field of expert performance, says, I believe the best approach would be to develop skills-based training programs. And this is what we try with our program. You should be able to do it. You should have the skill afterwards. You shouldn't remember every single detail, every single parameter, every single let's say, method attribute of a class, but you should have the skills to look them up, to apply them, to know what you do, and to deploy your stuff, and to not only have it on your machine. So therefore, training should focus on doing rather than on knowing. Although the first part is, of course, a little bit about knowing, you from the beginning are supposed to get started doing it and repeating it on your own. And this might be a little bit helpful in the sense of that there are no talents out there. There are no natural talents. So no matter where researchers have looked, the grandmasters, the youngest in the world in chess or whatever, almost always people required some years of intense performance. Usually they say 10 years or 10,000 hours. These are the numbers. But the basic conclusion here is no matter which area you study, music, dance, sports, competitive games, or anything else with objective measures of performance, you find that the top performers have devoted a tremendous amount of time to developing their abilities. And this form of mastery is not kind of something that you have reached one day. Mastery means that you try to master what you want to apply and what you want to do on a continuous basis. It's more an approach than something you might reach one day. So you need to invest in developing your abilities and skills. So in that sense, this is my last slide here. I'm closing with a quote which made me really happy from a student from the February 2018 cohort who said, well, I liked watching your videos. Of course, I like to hear that, but this is not why I was happy about this quote. I was happy about the second part. But it's much more interesting and educational to actually build something on my own. And everybody who has accomplished something on their own knows that. And even when I bumped into issues, I was able to fairly quickly find a solution, which is a testament to the quality of the available documentation for the technologies that we are using. So this is indeed, this would be my measure for success when people say, but it's much more interesting and educational to actually build something on my own. So strive for that, try it, and even if it's a simple, small example, start out simple, start out specific, get more general as you go, and then I'm pretty sure one day you will be a master in Python for algo trading and all the other sub-disciplines there. And with that having said, I have a final look at the questions that they were open. They again relate to the Python for algo trading certification and finance. So the major difference is the computational finance class, which is a very intense, and I would also say from a financial point of view, the most difficult one. The second question open here is with regard to the Quan platform. Similar to Quantopian, of course, Quantopian provides you with a good research environment, also with data to do research. We go a little bit further in providing more flexibility in this regard, and our focus is not exclusively on backtesting as Quantopian's platform is. We also do not have this social aspect with regard to publishing your results directly, but you have a user forum, you have kind of the learning aspect, the delivery aspect, and the execution aspect. So we are providing more flexibility with regard to what you can do on the Quan platform. Is more generic in that sense. I wouldn't say better or faster one. It's more generic in that you can do more in that, but this might require a little bit more work. But actually what we are here talking about is to master Python for algorithmic trading. Is not that you should expect kind of pre-packaged solution for plug and play. You get code, but you're supposed to adjust the code to work with it, to build your own thing. So again, we are here striving to get the best possible skills-based program. And afterward, you should be able to start from scratch and say, well, I learned all the things that Eve and the Python quants were teaching me. Now I got a new notebook and I get started from scratch and set everything up. And basically with what I recall, I can help myself and I can get started from scratch with setting up Python, using Docker, using the cloud, doing interactive analytics, working with financial data, accessing the APIs of platforms and so forth. So this is our approach to empower you to do Python for algorithmic trading, and after all, automated algo trading on your own. With that having said and answered the final open questions, again, for me, success would be measured on with regard to how you do it on your own, that you enjoy doing it and building it on your own, and then we will be happy with what we have achieved. In that sense, I wish you happy Python coding and of course happy algorithmic trading. See you in the next sessions. Take care. Bye-bye.